type 1 error when occurs when the null hypothesis is true, it's rejected. If the null hypothesis is rejected when it is true, that will be the type 1 error. This type 1 error, the probability of occurring type 1 error is our level of significance. So we are taking as 5% or 1% or 10%. Usually if there is any level of significance not specified in the problem, then we have to take it as a 5%. That is the common level of hypothesis testing. But in the medical context, we are taking a 91% level of significance. But in the social science, we are taking the 5% level of significance. Then the probability of occurring type 2 error, that is type 2 error occurred when if the null hypothesis is not rejected when it's false. Null hypothesis is not rejected when it's false. So there are 2 decisions and 2 errors we can get. This is the summary we learned in the last class. So now we are coming for the application part of hypothesis testing. Simply hypothesis is what? It is a statement we formulated based on the population parameter, not a sample statistic. Population parameter. And then whether this statement we formulated is possible to reject or not reject based on the sample information. That is the process, right? So now we are taking, we are going to test the hypothesis based on the population parameter mean mu. In confidence interval, here also we have 2 situations. We are going to take one hypothesis testing for mu when the sigma is known. If the population standard deviation is known, then we have to apply z-test. And when sigma is unknown, that's population standard deviation is unknown, then we are going to use t-test. Right? For the assumptions, always the population has normal distribution. Otherwise, if the population distribution is unknown, then we have to take sufficient sample size that will be 30 or more than 30. What are the assumptions we have in the confidence intervals, construction of confidence intervals? The same assumption here also we have to follow. Right. Then now we are coming for the situation. Hypothesis test for the mean when sigma is known. Right? When sigma is known. So here also, if sigma is known and the population is normal distribution, or we have enough sample size, then the sampling distribution of x bar is also normal distribution with mean mu and the variance sigma squared over n. So according to that, the z statistic, that means we have to take the standardized of x bar. So the standardized of x bar is z, that is equal to x bar minus mu over standard error, that is sigma over square root of n. For the confidence interval or for the hypothesis testing, all these are related things, right? So here, according to that, the z statistics we are using, that is defined by x bar minus mu over sigma over square root of n. The sigma is known. Right. Now here we look at this example. Right. The manager of a fast food restaurant wants to determine whether the population mean waiting time to place an order has changed in the past month from its previous population mean value of 4.5 minutes. Right? So here they are saying that from the previous month it is 4.5, but they believe that this month, the current month, this is changed from 4.5. But they don't have knowledge about whether it's improved the mean waiting time to place order improved or not improved, right? That part is not decided. That part is unknown. But anyway, they believe that the waiting time will be changed from the previous month that has 4.5 minutes. This is from the first statement summary, right? From past experience, it's assumed that the population is normally distributed with a population standard deviation of 1.2 minutes. This is regarding the informations regarding the population. So here, what is the population here we have? This is the waiting times. The population is the waiting times to place the order in a fast food restaurant. So this waiting times has normal distribution with standard deviation 1.2. Right? So then they are taking from this sample of 25 orders, right? During a 1 hour period is selected. During a 1 hour period, they select and they are picking up a 25 orders, right? The sample mean of waiting time is 5.1 minutes. From this 25 orders, they calculated the sample time, that is 5.1 minutes. Right? Then determine whether there is evidence at the there is evidence at the 0.05 level of significance that the population mean waiting time to place an order has changed in the past month from its previous population mean value of 4.5 minutes. Right? So for the current situation, they are following the current situation, the mean waiting time is 4.1. But now they want to check whether still the waiting time is 4.5 or not. Right? This is the summary of the problem. Right? So now this is the procedure. Now we look at, this is the procedure we have to follow. Right? So there are 6 steps procedure we have to follow. The first step, after getting the information regarding the problem, first we have to state the null hypothesis, H0, and the alternative hypothesis is H1. So to decide or to formulate the null hypothesis and the alternative hypothesis, first you have to identify what is the parameter involved in this problem. So in this problem, we are talking about the mean, right? Always this is we are looking at the waiting times. So the waiting time is a continuous variable, right? So the summary of this continuous variables observations, we can summarize using the mean value. So the mean is the parameter, population mean. So here the waiting time, mean of the waiting times is the parameter, right? Then according to that, then what is the, in which, after identifying the parameter, then you have to define the parameter related to this problem. Now we identify the parameter is a population mean relating to this problem. So what is mu? So usually population mean is denoted by mu. Now we have to define what is mu in this case. So in this case, mu is the waiting time to place an order in the fast food restaurant, right? Waiting time, mean waiting time to place an order. Here you have to identify how we can define the parameter. From this statement, you can identify. It is a mean waiting time to place an order. So mu denotes the mean waiting time to place an order. Then H0. After deciding this one, we can decide what is H0. H0, we know that always involves with the equal sign. So current situation, what is the mean waiting time to order? 4.5. So mu is equal to 4.5. Right? Then what is alternative? So here alternative, to decide alternative, whether it has a not equal sign or greater than sign or less than sign, right? So if we take the last statement, just they want to check whether there is evidence at 5% level of significance that the population mean waiting time to place an order has changed. So whether it's improved or not improved, that was not given in this problem. Only whether changed or not. So not equal sign. Then so H1 mu not equal to 4.5. So from the next slide we will write it. So now, according to this problem, our first step is stating the null hypothesis H0 and the alternative hypothesis H1. So here first we identified, from this problem we identified mean is the waiting time. Mean is the population parameter, and this population parameter denotes the mean waiting time, right? So now take suppose or let mu equals mean waiting time to place an order. To place an order at the fast food restaurant or in the fast food restaurant. Right? So after that only now we can start to write the things, right? So now follow the step 1, H naught. This notation you can use. This is a standard one. So here colon mark. What is your H naught? Now we have to specify this H naught. The mean waiting time is, now they say that it's a 4.5. So we are taking the mean waiting time as mu, that is equal to 4.5. Right? So without defining mu is equal to 4.5, we don't know what is mu. So before you are putting the notation, because there are different means are there. So here, when you are introducing a notations in the hypothesis test, then you have to write it. We know that mu denotes the mean, but which mean mu denotes? That you have to specify. So based on the problem, it is the population mean waiting time to place an order, right? So mu is equal to 4.5. Then H1 alternative. We want to test whether still it is a 4.5 or not. So mu not equal to 4.5. Now we completed first step. Then second step, choose the level of significance alpha and the sample size, right? So here they say that determine whether there is evidence at the 0.05 level of significance. 0.05. So level of significance usually denoted by alpha. Alpha is equal to 0.05. And what is your sample size here? They took 25 orders. So n equals 25. This is your step 1 and this is your step 2. Then what is step 3? Determine the appropriate test statistic and the sampling distribution. So to decide the sampling distribution, we have to know what is the distribution of population. So here they say that in the past month, its previous population mean 4.5 minutes. From the past experience, it's assumed that population is normally distributed, right? With a standard deviation 1.2. So, population here mean waiting times. According from the given scenario, the waiting times X. Waiting times X has normal distribution. The mean is unknown with what is the standard deviation is 1.2 with sigma is equal to 1.2. Therefore, now what is our, according to the mu, the corresponding statistic is X bar, sample mean. So X bar has normal distribution with mean mu, right? It is unknown. We have to decide, right? With mean mu and the standard deviation sigma squared over n, that is 1.2 squared over n, 25. So from this, now we can our test statistic. Z equals X bar minus mu over sigma over square root of n. So that is equal to, right. Later we can calculate, right? Now up to step 3 we have completed. Up to step 3 we have to complete, right? So this is our sampling distribution. X bar has normal distribution with this sigma squared over n. So because why here we are saying that it's normal? Because the waiting times already they from the past experience, they found that this waiting times has normal distribution with sigma is equal to 1.2. Right? So you note it, then I'm going to take the next slide to continue. Up to step 3, we completed, right? Right. Now we are moving to the next slide. Now in the step 3, we have test statistic Z is equal to X bar minus mu over sigma over square root of n. Right. In the fourth part, determine the critical values that divide the rejection and non-rejection region. Now we have to determine the critical values that divide the rejection and non-rejection regions, right? That means the critical values are, we have to find the unlikely values. The rejection region consists of the unlikely values of X bar, which are not coming from the current population, right? We have to decide the range of the unlikely values of for X bar, which are not possible from the given population, right? So, but which these unlikely values form a region. That region is called the rejection region. So, to determine the rejection and non-rejection region, we have to need the knowledge of alternative hypothesis, right? So, from the previous slide, we have, here I am writing the H naught and H1. H naught mu is equal to 4.5 and H1 mu not equal to 4.5. So based on the H1, it is a not equal sign. So first we have to decide whether it is a one-tail or two-tail test. So it has not equal sign, then the test is two-tail test. Based on the alternative hypothesis, we are deciding it is a two-tail test. Right? And we know that so it's a two-tail test. Then your alpha is 0.05. Alpha by 2 is as a two-tail. Then this alpha should be equally divided for both tails. So that is 0.02. Now, according to this one, we have to draw a rough diagram. This is Z. So as a Z distribution, this value is 0. This is 1 and this is 1. This is Z alpha by 2. And this is symmetrically minus Z alpha by 2. Here, this is alpha by 2. That is 0.025. And this is also alpha by 2. That is 0.05. And these are the rejection regions, right? These two are the rejection region. And this is the rejection region for H node. This is also rejection region for H node. Right? So now we know that if the corresponding Z values, so from the table, now this is 0.0475, right? This is 0.475. So from the standard normal table, now we have to identify the critical values, right? From the standard normal table, probability of 0 less than Z less than Z alpha by 2. Is equal to 0.025. So if we want to get this area is 0.475. So from this we have Z alpha by 2 is equal to 1.96. Okay? So this is 1.96 and this is minus 1.96. So if your Z statistic, this value, this is Z. If the Z is greater than 1.96 or Z less than minus 1.6, then you have to reject H naught. So now we identify the critical values. These are the critical values, right? From the table, the critical values are Z alpha by 2, that is 1.96. This is called a critical value. This is the region. This is the boundary point that divides the unlikely values and the likely values, right? If Z greater than 1.96 or less than minus 1.6, then it is the unlikely values. Then we can say that this sample is not possible to get from the population. Right? If this test statistic falls within this region, right? then these values, the values in between minus 1.96 to 1.96 are likely values, and we can say that yes, the sample is possible to get from the corresponding population, right? So from this, now we have to decide now we identify the rejection and non-rejection region, and these two are the boundary points for the rejection and non-rejection region. So critical values define the region as a rejection and a non-rejection region. That is the minimum or maximum point. Right? So now based on this one, our decision rule determine the critical values that divide the region and the non-rejection region. So from this, the decision rule, we can form reject H naught if your Z means your test statistic, right? If your Z greater than 1.96, if the test statistic that is denoted by Z greater than 1.96 or Z less than minus 1.96. This is coming under step 4. Right? So now we have to ready to calculate collect the data and compute the value of the test statistic. Right? So now we are going to move to the next slide. Take 1 minute and note it. Right. Here, repeat, I am writing the step 4 with the diagram. Diagram that minus 1.96. Sorry, it is plus 1.96. It is minus 1.96. So this is your rejection region. This is also rejection. Decision rule or decision criteria. Reject H naught if that your test statistic greater than 1.96 or less than minus 1.96. Right? Greater than 1.96 or less than minus, because if your Z values are false in this region or either in this region, then there is a possibility of rejecting H naught at the given specific level of significance. Right? So now we are ready to step 5 to follow. Step 5, collect the data and compute the value of the test statistic. From the step 2, we have Z equals X bar minus mu over sigma over square root of n. Right, that is X bar. From the here a sample of 25 orders during a 1 hour period is selected. Time is 5.1. So it is 5.1. Mu, right? Mu means under H naught, what is the value, right? So here also we have to know our H naught. Right? H naught mu is equal to 4.5 versus H1 equal to 4.5. So what is the value? It's because we are saying that the current mean is 4.5, right? So the current mean value is 4.5. So now it is said that mu is equal to 4.5. Because we are under H node only, we are performing our test, right? And sigma, our population standard deviation, that is 1.2. Divided by square root of n, 25. When you are simplifying this one, you get as the value 2.5. Right. Now where the 2.5 is greater than 1.96, right? Now we are, after computing this value, right? Now we have to make the decision. Now we collect the data and compute the value of the test statistic. So now we have to follow step 6. Make the statistical decision and state the managerial decision. Right. Now, based on our decision criteria, for the statistical decision mean, you have to decide whether it's reject H naught or do not reject H naught. Right? That is the statistical decision. So under statistical decision, what we are making, we have to find out or we have to determine whether H naught is rejected or not rejected. Right? So if the test statistics falls into the non-rejection region, then do not reject null hypothesis. Right? If the test statistics falls into the non-rejection region, then do not reject the null hypothesis. If the test statistics falls into the rejection region, then reject the null hypothesis. This is the rule we have to follow. But here we form that according to the given scenario, at the 5% level of significance, Z greater than our rejection region, if the test statistic value is greater than 1.96 or minus 1.96, then we have to reject H naught. So now it is 2.5, it is here. This is the 2.5. So our test statistics falls in the rejection region. So there is evidence at 5% level of significance to reject H naught. In such manner, you have to write the statistical decision. So when we are rejecting the H naught, we have to say that at what percentage of significance level we are rejecting the H naught, right? So now here for the statistical decision, under step 6, there are two decisions we have to make. One is the statistical decision, then the managerial decision. So first we are writing the statistical decision. To reach the statistical decision, we have to compare the test statistic value and the critical value. This is the critical value, right? As since test statistic, we got our test statistic is equal to 2.5 greater than 1.96. That is the critical value. There is enough evidence. So what we are going to do? It is a greater than 1.96. So reject H naught. So there is evidence. There is enough evidence. There is enough evidence to reject H naught. What is the level of significance V2? 5%. At 5% level of significance. So this says that this sample, so sample, what is the sample we collected? That sample is not possible to come from the population with mean value 4.5. What is the meaning of this one? Reject H naught means this is the unlikely value. Because we say that this mean value is coming from the population which has mean value 4.5. Right? Under that assumptions, we calculated this mean value, this test statistic value. But now from the evidence, we got that this 5.1, this sample mean 5.1 is not possible to get from the population that has mean 4.5. So if H naught is rejected, so now we say that mu is equal to not equal to 4.5. Right? So the population mean, if this is the sample, right? Our sample is 5.1, now sample mean. So if this is the sample mean 5.1, then it says that this 5.1 is not possible to come from the population that has mean 4.5. So from this, we can say that mu not equal to 4.5. Not equal to 4.5 because reject, there is enough evidence to reject H naught. So if we are rejecting H naught, then what is our decision? It is rejected. So H1 will be the decision. Then mu not equal to 4.5. Now this is our statistical decision. Right? So not it now for writing the managerial decision. Okay. Now we come to the managerial decision. One more slide I need. Slide, right? So, right. So now our step 6, we are continuing. Our statistical decision, we found mu not equal to 4.5. So now what is our managerial? What is the conclusion you are giving to the management? They can't understand you if the statistical knowledge people only understand what is mu not equal to 4.5. So now in a simple our business language, we have to make our conclusion. So managerial decision. According to the problem, now we say that determine whether there is evidence at the 0.05 level of significance that the population mean waiting time to place an order has changed in the past month from its previous population, right? So now it is not 4.5, so it's changed. Now the time is changed, right? So now we say that the mean waiting time mu not equal to 4.5. So the mean waiting time to place an order has been changed. Has changed, right? The mean waiting time to place an order has changed from the previous month mean waiting time of 4.5 minutes. Right? Similarly, you have to follow the steps. The mean waiting time to place an order has been changed from the previous month mean waiting time of 4.5 minutes. From this statistical decision, now this is converted to this managerial decision. So, but we don't know whether the time is less than 4.5 or greater than 4.5. That's we cannot say that. Now we can say that what happened, whether it's increased or decreased. Anyone? Unmute the mic and say that whether now it's this waiting time is increased or decreased. Looking at the sample mean, you can say that. What is the sample mean you got? We got our sample mean is 5.1. The sample mean waiting time is 5.1. So now this will be the point estimate. So thus this sample indicates that the mean waiting time has increased. Right? So from the sample mean indicates the sample mean waiting time shows the mean waiting time to place an order has increased for the current month. Mean waiting time has increased. From 4.5 to 5.1. Now the system is not efficient, right? Now the system is not efficiently working. The waiting time has increased, so the system is not working properly, right? So it will create the customer's dissatisfaction. So they have to improve their service quality. Such kind of thinking you need, right? Right. So now how we are going to, now I indicate how the marks will be allocated for these problems. Step by step, right? Suppose here we are taking for the 10 marks. Right? For the question 1, state the null and alternative hypothesis. Here 2 marks will be allocated. 1 mark for defining mu in the statement format, right? To identify the proper parameter and define what is mu. That for 1 mark. And 1 mark for your both null and alternative hypothesis. Right? Choose the level of significance and the sample size. Maybe half or 1 mark will be provided. Determine the appropriate test statistic and sampling distribution. 1 mark. Because only for these are the things you have to remember. Right? Then critical values, 1 mark. So if you're not giving properly right what are the steps we are expected, then half a mark will be provided. If the complete steps you are providing, then you will provide the 1 mark. So up to this, the 5 marks we will give. Then for the computing, 1 mark. So nearly 6 marks. Here up to 5 completed, we have 6 marks. Then statistical decision, right? To write this one, properly to write this one, 2 marks, right? Because the decision properly, you have to, if you are clearly in writing, 2 marks, otherwise 1 mark will be provided. Then for managerial decision, write 2 marks. Because the conclusion is very important, right? So the 4 marks is allocated for part 6, step 6. Then another 6 marks will be allocated from steps 1 to 5. So each and every step is following appropriately is essential, right? It's starting from defining the notation mu and ending with the conclusion. Right? This is the method the marks will be allocated. So according to that, you have to also follow the procedure. Nearly 30 marks question you will get from the confidence interval estimating and the hypothesis testing. Right? Nearly 30 marks we will allocated. The weightage, nearly 30-35 marks will be given for the sampling distribution, statistical hypothesis testing, and for the confidence interval estimation. Right? Nearly 30 marks you will get. 30 or 35 marks will be allocated for this 3 sections: sampling distribution, confidence interval estimation, and hypothesis testing. So nearly 1/3. So it's very important. Don't omit the section. The last batch, right? Nearly they didn't touch this section. So their marks is average marks for the class is 26. Very poor performance, right? So most of the students are going to get a fail in that in this subject because they didn't touch this section, right? And they are going to almost they are going to get the nearly 40% of the students are going to get the fail marks in this subject. Similarly, now the business mathematics, right? Now I am marking your paper. That's on the way. When looking at the papers, nearly 50% of the students, they did very well. Almost B or more than B, nearly 50% of the students going to get. But nearly 40% of the students, they did very poor, right? One day I will call them and I'm going to talk with them, right? They never prepared they didn't do anything for the maths. That indicates they didn't prepare themselves. But this nearly 60 or 50% of the students, what is the thing I taught in the discussion class, right? properly, they follow the steps and everything. They very well, clearly steps they maintain, and nearly more than 30 or 40%, 25 to 30 students, 30% of the students, they are going to get A grade. They follow proper steps, right? They clearly define their steps and follow the proper steps, and they reach the final calculation without any error. Perfectly, they followed what are the steps I taught in the discussion class, they follow, right? So that's very good. But another 40% of the students, I'm very sad, because they never, what are the even single step I taught in the discussion class, they didn't follow, right? What are the common errors you are making? I told in the discussion class, that also they didn't follow it. And even one step or also, even one example also, they didn't. What are the sections we learned in the class and what are the examples we done in the class? They never touch it, right? Very poor marks, less than 20 marks in the paper. Then how they are going to get the pass marks? So here also nearly 40% of the students are going to fail their first semester exam. So even this subject, if you are not studying properly, the same set of students, definitely they will get the fail marks in the statistics also. This time also, even not in the face-to-face, I will do the discussion of the model paper. I will upload the model paper after completing the syllabus. Then you have to, after studying properly all the chapters, then you have to do the model paper and you have to be ready for the discussion, right? I will make the discussion through the Zoom discussion, or I don't know whether if it's possible, then we have to have face-to-face discussion. Otherwise, the Zoom class discussion I will have for the model paper that will be uploaded. So after revising your sections, then you have to do yourself with the model paper, and then what are the discussions when we are making and what are the errors you are making, then you can correct it, right? So these three sections are very important and you have to study well these three sections to get the marks, right? Right, now this for exercise, I simply give some steps, then you have to complete it, right? A phone industry manager thinks that customer monthly phone bills have increased and now over rupees 520 per month. The company wishes to test the claim at 10% level of significance, right? So here from this one, and assume sigma is 100 and N is equal to 64. It's regarding the amount of phone bills, monthly, the charge, monthly phone bills charge, right? Now they believe that it's over 520, more than 520. So now current situation, their monthly phone bill is, average monthly phone bill is 520, but now they feel that it's increased over 520 per month. So now they want to check whether it's increased. They want to check. So first, this is also phone bill charge. That is a continuous variable that is measured in the rupees. So it is a continuous variable. So the appropriate parameter is mu. We can summarize the average. They also mentioned that average. Right? So the parameter related to this problem is population mean. Right? So now we are taking the parameter. We identified our parameter is population mean. So now we are going to define mean. Mu that is equals to average or mean of population mean, right? Mean of, whenever mu denotes the population means. That's why here we are not mentioning. Mu always denotes the population mean, right? Mean of monthly cell phone charges. Mean of monthly mean of monthly cell phone charges of customers. Mean of monthly cell phone bills or charges, right? Charges of customers. Right. Now we can come with the step 1, H node. What is H node here? H node is the current situation. The monthly charge is 520. Mu equals 520. This is a colon, right? This H node states that the monthly phone bill charge is 520. Then H1, your alternative hypothesis, they say that the cell phone bills have increased. This term, right? So mu greater than 520. Always it has, under null hypothesis, mu should be 520. And H1 mu greater than 520. Now we completed step 1. And if you define these two things, then you will get 2 marks, right? Then step 2, level of significance and the sample size, alpha. They said 10%. That is 0.1. And the sample size, n equals 64. Right? So for this one, you will get 1 mark. Then 3, determine the appropriate test statistic. So here the population distribution we have to talk about. Here we don't know the population distribution, only we know that sigma is equal to 100. So the population distribution is unknown, but the sample is greater than 30. So from this we can specify the sampling distribution, right? So as according to the central limit theorem, as n greater than or equal to 30, x bar has normal distribution with mean that is unknown, and the standard error sigma squared over n, sigma is 100. So 100 squared over 6. How we specify this one? Central limit theorem. Our central limit theorem. So the Z statistic, the test statistic is Z. And sigma is known, right? So the test statistic is Z. That is equal to x bar minus mu sigma over square root of n. Right? Now we are going to follow the next step. Not it, then I'm going to take the next slide. Right. So now our fourth step. Determine the critical values that divide the rejection and the non-rejection period. So we have to identify whether it's a one-tail test or two-tail test. So based on the H node is from step 1, mu is equal to 520 and H1 mu greater than 520. Right? So based on this one, it is a one-tail right-tail test, right? It is a one-tail right-tail test. It is a one-tail right tail, upper tail or right tail, right? One tail, right tail test.
ஐயோ மாமாக்கு நாய் கடிச்சாலும் தனியா ஒரு தடவை விட்டா கூப்பிடுங்க
And it's a one-tail right-tail test, right? So alpha by 2, then also we need the alpha by 2. (0.1 divided by 2, that is 0.05. Then now we can draw the diagram based on the alternative hypothesis and the level of significance. Your diagram. Zero is Z. Only one tail. Not here, sorry. For the two tail only, we have to take alpha by 2. It is only alpha, that is equal to 0.1. This is 0.1. And this is Z alpha. The critical value is Z alpha. Right? 0.4 from the table. The critical value Z alpha, that is at 0.1. Can you say anyone what is the Z alpha value in between 0 to the area should be 0.4? That is your probability of 0 less than Z less than Z alpha is equal to 0.1, 0.4. So from the table you can find out. Table 0.4 means nearly there is a 0.3997 and 0.45. Then I think from this is equal to 1.28. 1.28. So this is the critical value, right? And your decision rule, this is 1.28. So decision rule, reject H naught if the test statistic value Z greater than 1.8. Right? This is the rejection region of H naught. And step 5, compute the test statistic. Right? So our test statistic is Z equals X bar minus mu over sigma over square root of n. X bar, the current mean value, there is a problem, right? Take here, X bar also not given, right? Take X bar is equal to 524. Take X bar is, include in your problem, take X bar is equal to 524, right? So the mean value 524 minus mu, that is 520. Sigma 100 over square root of n, 64. Now you can get this value, right? Now you have to calculate this one. If this value is greater than, what is your value is greater than 1.28, then you can reject H naught. Right? If your Z value less than 1.28, then there is enough evidence to not reject H naught. There is enough evidence to not reject H naught. If greater than 1.28, this value, there is enough evidence to reject H naught at 10% level of significance. Then if you reject H naught, then your statistical decision mu greater than 520. If there is enough evidence to reject H naught, then the statistical decision will be mu greater than 520. Then what is the conclusion? Managerial conclusion. The customer's monthly bill increased over 520. The average increased over 520. If there is enough evidence to not reject H naught, then mu is equal to 520. So the monthly phone bill is still 520 and not increased over 520. That part you have to complete, right? Then part 6. After calculate this one, then you have to reach part 6. Right? So here, take this value as 524. X bar is equal to 524. Right? Right. Now we are coming for the next section. Test statistic of hypothesis for the mean unknown. Sigma is unknown. Right? Hypothesis test for mu. If sigma is known, then you have to use this as a test statistic. And sigma is unknown, right? Then this sigma should be estimated from the sample observation. So the test statistic will be t distribution with n-1 degrees of freedom. Then as it is in the confidence interval estimation, right? That is now defined by x bar minus mu. And this sigma will be replaced by the sample standard deviation over square root of n. So in this case, the standard error is s over square root of n. Right? Now, the steps all are same, only the test statistic will be changed. So now we are coming for the next example. It's the average cost. So the first statement indicates our parameter will be mean. The average cost of a hotel room in a particular city is said to be $168 per night. A random sample of 25 hotels resulted in the sample average cost of 172.50. They take a 25 hotels and the standard deviation is $15.40. Test whether the average cost of a hotel room in a particular city is $168 per night at the 5% level of significance. Assume the population distribution is normal. Right? Now say that it's 168. So now we have to check whether still it's 168. That's the information we have, right? Now they believe that it's 168. But when we are taking the sample, it hits 172.50. The hotel rate has increased according to the sample. So now we want to check still it's 168 or not. Right. So now step 1, we have to identify the parameter and define what is the parameter and form the null and alternative hypothesis. So first we are defining our parameter is the population mean. So that is denoted by mu. That is equal to mean cost of a hotel room, right? In a particular city per night. Mean cost. Clearly you have to define. Don't write just mean cost, right? Clearly you have to specify what is mean. Mean cost of what? Of a hotel room. Cost of a hotel room in a particular city mean cost of a hotel room in a particular city per night. From the problem, you can get the idea, right? Right? Then H naught. Now we are ready to define H naught. The current hotel charge is 168. U is equal to 168. But now they want to check, still it's 168. So H1 mu not equal to 168. From the sample observation, it indicates the hotel charge increases. But that means that still it is 168. So now we want to check whether it's increased or not, mean hotel charge. Right? So for that, we take a sample of 25 hotels, and from that we want to find whether it's still 68 or increased. Right. It's our step 1. Then step 2. Determine the appropriate test status. Sorry, choose the level of significance and sample size. Level 0.05. Alpha is equal to 0.05. And then sample size is 25. N is equal to 25. Step 3. Appropriate test statistic. So now to decide the test statistic, we need the sampling distribution. Now X bar has a normal distribution actually with mu is unknown and sigma. That sigma is also unknown over n. That is 25. Because why here we are taking it's a normal distribution, we say that the population distribution is normal. But sigma is unknown. Now the test statistic, we can't use Z. Why? Because sigma is unknown. Our test statistic T with degrees of freedom n minus 1, that is X bar minus mu over S over square root of n. Right? Why? Because of sigma is unknown, then we can't take Z as a test statistic. We have to take, instead of Z, we have to take T. But if you want to specify T, the degrees of freedom should be specified. Because of this sigma unknown, we take the test statistic as T. Right? Now we come up to complete part 3. Right? Now we are coming for part 4. Step 4. Right? Into the slide. Step 4. We have to decide the critical region and the critical values and the critical region. So first we have to decide whether it's a one-tail or two-tail test. Our H naught mu is equal to 168. And H1 mu not equal to 168. So from this one, it's a two-tail test. Right? And so then your alpha by 2, that is 0.5% level of significance divided by 2, that is 0.05. Diagram. Zero point zero five. 0.05. These two are the rejection region. It is 0. Then it is Z alpha by 2. It is minus Z alpha by 2. Right? So from the standard normal table, Z alpha by 2 equals 1.96. So now we can form the decision criteria. Reject H naught if Z greater than 1.96, Z less than minus 1.96. Because these two are the rejection region. If this test statistic value is greater than the critical value 1.96, within this region, if your statistic falls within this region, then reject H naught. Otherwise, or not to reject H naught. Now step 5, compute the test statistic. Sorry. Now from the T table, right? It is T. Very sorry. Alpha by 2, right? So now here we have a T distribution. It's also around. It is 0.025. It is 0.025. It is T n minus 1 alpha by 2. It is minus T n minus 1 alpha by 2. Right? So from the T table, the T distribution table, t n minus 1 comma alpha by 2. That is equal to t. What is n value is 25. So that is 24 comma alpha by 2 0.025. So from the table, when you are taking, this is the row value and this is the column value, where the corresponding row and column intersected. In that point, this value is 2.064. Now this is equal to 0.064. This is equal to minus 2.06. The decision criteria now. Reject H naught if the test statistic, this one, right? T n minus 1 greater than 2.064 or t n minus 1 less than minus 2.04. How we are making? As for the Z, similarly here also we are making reject H naught if Tn minus 1 greater than 2.064 or Tn minus 1 less than minus 2.064. Right? Then part 5, computing test statistics, or Tn minus 1, that is equal to x bar minus mu over s over square root of n, that is equal to x bar (172.5), I think. 170.25, and S is equal to 15.40. 172.5 minus mu. What is the value we specified under H naught? 168. Divided by S, standard deviation sample, 15.4, divided by square root of n, 25. That is equal to 1.46. Right? So then our decision. Now, statistical decision. What will happen? This is 1.46. That is less than, right? Less than 2.064. So it will not be rejected, right? Because if you want to reject H naught, our statistic value 1.46 greater than 2.064. But here, this value is less than 2.064. So we are not able to reject H naught. Our statistical decision as Tn minus 1 is equal to 1.46. It falls in the non-rejection region, right? Less than 2.064. Right? There is enough evidence to not reject H naught. Not reject H naught at 5% level of significance. There is enough evidence to not reject H naught at 5% level of significance. That is, if we are not rejecting H naught, then mu is equal to 168. Mu is equal to 168. So that means this sample is possible. But it says the sample of 25 charges, hotel charges are possible to come from the population which has mean 168. Right? It's possible come from the population which has mean 168. Therefore, your managerial conclusion or managerial decision because mu is equal to 168. So the mean cost of a hotel room, therefore the mean cost for hotel room is $168. Right? Okay. Right. Now we are coming for the next slide. This exercise I am leaving as a homework, right? You read the problem carefully and follow all these steps and you have to complete. But here, the sample in the previous problem, this is also a small sample. So the population standard deviation is unknown. So you have to get the population standard deviation, right? But in the previous example, X bar and the S were given, but in this problem you have to calculate, right? So to calculate X bar, you have to calculate, that is summation Xi over N. So that is equal to 1089.98.80 plus add all the figures 11351.10 divided by N. That is how many samples they took? 12. Then S squared is equal to 1 over N minus 1. Summation of I is equal to 1 to N Xi minus X bar whole squared. You have to use this formula. So this is equivalent to 1 over N minus 1. Summation of I is equal to 1 to N Xi squared minus summation of Xi whole squared divided by N. By applying this formula, you can get S squared. Then S is equal to square root of S. Then what is the procedure we are doing? You have to complete this one. This part, you have to come under the chapter part 5. Step 5, you can complete these steps. Okay? Right. Now, proportion. It's similar for hyper confidence interval. Here we are taking the categorical variable. It involves in the In the previous two cases, it's involved with a continuous variable, but here the problem is involving with the categorical variable. So if the variable is categorical, then you have to take the proportion hypothesis test. And two possible outcomes, one is success, another one is failure. The fraction or proportion of the population in the success category is denoted by pi. And as it is in the confidence interval, the sample proportion denoted by P, that is x over n, that is given by this one. And here also, this sampling distribution of P has a normal distribution with mean pi and the standard deviation square root of pi into 1 minus pi over n. N is the total sample size. But what is the condition here we have to check to say it's a normal distribution? N pi and n into 1 minus pi are at least 5. Right? Then P can be approximated by a normal distribution. Then for the test statistic, it is a Z that is defined by P minus pi divided by pi into 1 minus pi over n. Definitely, if you want to apply this test statistic, then n pi greater than or equal to 5 and n into 1 minus pi greater than or equal to 5. Right? Then here I am quickly do this example. A marketing company claims that it receives 8% response from its marketing company claims that it receives 8% responses from. So the response rate for the mail is 8%, correct. To test this claim, whether now still it's 8% or not, a random sample of 500 was surveyed with the 25 responses. For the sample of 500 mails they sent, but they received only 25 responses. Tested alpha is equal to 0.05. Right? So here the parameter is proportion. So that is denoted by pi. So now here we are taking pi as a parameter, which is the proportion of responses received for the mail. Proportion of responses received for the mails. Right? Then H naught. Mu, the current proposed responses rate is 8%. That is 0.08. Now we want to check still it is 0.08. So mu is equal, sorry, it is pi. Not equal to 0.08 is step 1. And step 2, alpha is equal to 0.05 and your sample size 500. Right? Then step 3, sampling distribution. Pi has a normal distribution, sorry, the parameter is statistic is P. P has normal distribution with mean unknown, and this is pi into 1 minus, you can calculate, right? Pi into 1 minus pi over 10 because the criteria n pi and n into 1 minus pi. N pi, that is 500 into 0.08, that is 40. And n into 1 minus pi, that is 500 into 0.92. That is also greater than 5. Both are greater than 5. Therefore, because of this, we can say that it has a normal distribution because of this condition. Therefore, your test statistic is Z, that is equal to P minus pi over square root of pi into 1 minus pi over n. Right? This is the test statistic. Then you have to complete steps 4, 5, 6, right? It is a two-tailed test, right? And the alpha is 0.05. So the critical value is 1.96. So if it's a 0.9, your test statistic greater than or less than, greater than 1.96 or less than minus 1.96, then you can reject H0 from the decision criteria as in the 3 examples we did earlier. Right? After formulating step 4, after step 5, collect the data and compute the value for the test statistic. Now P, what is P value here? P value is only 25 responses they received. So P is equal to 25 over 500. Right? So that is 0.005 or something, right? 25 over 500. Right? 0.05 P. Then applying this formula, you can get the pi is known, that is 0.08. From that, actually you got, I think Z value is, check with that, minus 2.48. So it is less than minus 1.96. So here also there is enough evidence to reject H0, right? So if it's a reject H0, then your conclusion pi not equal to 0.8. So what is the decision? The proportion of the responses received from the marketing company is, marketing company's mails is different from, it is not equal to 0.08. So it is different from 0.08. Right? So this one. And this is for another exercise. This is also you have to complete. Then reference how we can do hypothesis testing using the confidence interval. That will be, you have to read the materials and then you have to find out. And also practice some examples from the notes uploaded, right? The notes uploaded, there are so many examples are there. There are, they practice with the solutions, the steps and the solution. There are so many examples given in the reading material uploaded for the hypothesis testing, confidence interval or sampling distribution, right? From those, even you are not following the exercises, do the examples there with the steps. They show those examples, you can do it, right? So from that, you can learn it. So now we completed this hypothesis testing procedure. Then I have another lectures I have to put to you for the regression analysis, correlation and regression. Then also Dinesh sir will take 2 lectures for the time series and the quality control, right? That will cover by Dinesh sir. He will inform the time to you. My lectures, regression analysis, I will inform tomorrow or day after tomorrow when we will have the lectures, right? Then in nearly 3 lecture session, we will complete all the syllabuses. Then from the next week onwards, I will put the schedule. You will have the exams part by part, right? So anything you want to get from me? My lectures time, I will inform later. Through your class rep, it will be informed to you, right? But usually the morning schedule, I will have from 6:30 to 8:30. Okay, ending session.